In this paper, we introduce SuperPADL, a framework for scaling up the training of language-directed, physics-based animation models to datasets containing thousands of motions. Reinforcement learning has been an effective paradigm for training controllers for physically simulated characters. These models can be controlled through a variety of different interfaces that offer users different levels of control over generated motion. Of particular interest is natural language, which offers an intuitive and expressive interface that is accessible for both expert and non-expert users alike. However, it can be difficult to scale up RL to train language-directed controllers with large motion datasets. In this work, we present SuperPADL, which augments reinforcement learning approaches with a progressive supervised distillation method to train a large-scale, language-directed controller for physically simulated characters. Our controller can reproduce skills from a dataset containing over 5,000 motions. Our system runs in real time and can respond interactively to changes in the user's commands. SuperPADL consists of 3 stages. First, we train separate expert motion tracking policies on every motion in our dataset. Next, we partition our dataset into random groups and train a multi-motion controller on each group using a hybrid RL and distillation objective. Lastly, we distill together all of our group controllers to train a single, global, text-conditioned policy. In each stage, we progressively produce more general-purpose and capable models. At the same time, our training objectives evolve from pure reinforcement learning in the tracking stage to a hybrid RL-BC approach in the group controller stage to a purely supervised distillation objective in the final stage. The global controller can reproduce thousands of motions from text prompts, ranging from simple locomotion skills to more complicated behaviors such as dancing and martial arts. The global controller also inherits the abilities of the group controllers to naturally transition between skills in response to changing commands. Our policy runs in real time on a single GPU, allowing for interactive character control. We compare our global controller to 2 reinforcement learning baselines, directly applying PADL to our full dataset and applying the same PADL plus behavior cloning approach as our group controllers. Both baselines struggle at this scale and are unable to generate motions with the same quality as SuperPADL. Our global controller still has limitations. For certain skills, such as ballet dancing, the global controller is unable to generate high-fidelity motions. Additionally, the character can still fall over. In particular, the character can fall depending on the timing of a transition during a difficult motion. For example, when the policy is instructed to crouch midway through a kick, it will fall over. However, with slightly different timing, the transition is successful. The policy is also still sensitive to paraphrasing, with small changes potentially affecting motion quality, or in particular, whether the model can exit the initial standing pose. For more details, please check out our paper. Thank you for watching.